Hello everyone, let's review some right triangle trig. Look, I'm a floating head today. My Mason green on my green screen. So, right triangle trig. Before I do one like this with actual numbers, let me just show you how you've got an angle here, and when we are on the x-axis, we will usually call this the reference angle. I'll come back to that. But this is my reference angle, and one thing you need to understand is that if this is your angle, then you first should identify the hypotenuse. The hypotenuse is always across from 90, so that's the longest leg, and that should be the easiest one to spot. So if it's not the hypotenuse, your decision you have to make, is it opposite the angle? Is it across from it? Does the angle open up to form that side? If it is, we call that the opposite. Or is it the other one that's not the hypotenuse? That's called the adjacent side. So if it's the one that shares the vertex with the hypotenuse, that's called the adjacent side. The one that does not share the vertex is called the opposite side. So if I say, what is the sine of theta? Opposite over hypotenuse. Here the opposite is y and radius is r, so y over r. Cosine is adjacent over hypotenuse, so that would be x over r. And tangent is opposite over adjacent, which is y over x. Maybe you remember SOHCAHTOA, and that can help you, because what this is telling you is that sine of an angle is opposite over hypotenuse. So S-O-H, SOHCAHTOA. Cosine is adjacent hypotenuse, so that's the C-A-H, C-A-H. Cosine is adjacent hypotenuse. And tangent is opposite over adjacent, so TOA, T-O-A. Okay? If SOHCAHTOA helps you remember them, great, but you definitely need to know them. In addition to the basic three trig functions, we have what are called the reciprocal functions. And the reciprocal functions, reciprocal is not the same as inverse. Reciprocal is when you flip the fraction. So cosecant is the reciprocal of sine, so this would be r over y. Another way of saying that is hypotenuse over opposite, because if you flip this, it's be hypotenuse over opposite. Secant is the reciprocal of cosine, so r over x, or hypotenuse over adjacent. And cotangent is the reciprocal of tangent, x over y. Common mistake, people really want cosecant to be the reciprocal of cosine because they sound like they start the same way, but they are not reciprocals. Cosecant is the reciprocal of sine, and you need to remember that. Okay, so those are your 6 trig functions we're going to work with. And now I'm going to give you one with numbers, and notice how theta has moved. So in this problem, the opposite side is 7, and the adjacent side is 4. To find the missing side, I will do Pythagorean theorem. So a squared plus b squared is the radius squared. That's 28 plus 16. 28 plus 16 is 44, and I'm going to practice, because we've done this in this class, 44 is 4 times 11, so I will call this 2 radical 11. Okay, when you square root that, square root of 44 is 2 radical 11. Okay, so now I'm going to find the trig ratio. So sine is opposite over hypotenuse, 4 over 2 radical 11. Cosine, oh wait, no, that's wrong. Watch, because theta is up here. So opposite is 7, and then 2 radical 11. We almost always are working from the x-axis, but in this problem, theta is up here. So opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent, 7 over 4. Now, if you have those, the reciprocals are easy because sine is the cosecant, or reciprocal of cosecant. So flip it, 2 radical 11 over 7, 2 radical 11 over 4. Can't really tell what that says. 2 radical 11 over 4, or 4 over 7. Those are the reciprocals. So you should expect to do Pythagorean theorem. You should expect to simplify some radicals. And once you do that, then you can get all 6 trig functions. Now, if you're asked to solve, you definitely need a calculator. And your calculator definitely needs to be in degrees. So on a TI-84, you go to mode, and you can see how degree is selected. You can also see it at the top of the screen. If you have a different calculator, you just need to make sure it's in degrees. If you're getting the wrong answers, you're probably in radians. So in this problem, if I want to solve for these missing sides, let's see. Do I know it? Well, remember, big X is the angle. So the angle, I know that one's 90 degrees. I know big Y is 65 degrees. And hopefully you remember in a right triangle, or in any triangle, the angles have to add up to 180. So 180 minus 90 minus 65, this is 25 degrees. Now I have all three angles, but now I need to find the sides. All I know, xy is little w, that's 5, and that's because big W is opposite little w. Little y is opposite big Y. Let's do a trig function here to find this one. So to find this missing side, I'm going to use the 65 and the 5. So that would be opposite. This is opposite, and this is the adjacent side. So opposite adjacent, which trig function should I use? Opposite adjacent is tangent. So I'm going to write an equation. The tangent of 65 is opposite, that's my little y, over adjacent 5. And to solve this, you're going to multiply both sides by 5. So my calculator, 5 tangent 65 is 10.72. What's it say to round to? It doesn't say what to round to, so I'll just keep 2 decimals. 10.72. 10.72 is little y. 10.72. Now you could do Pythagorean theorem, but just because I want to practice, I'm going to do another trig function. So to find the hypotenuse, I'll use 5 and 65, so that would be the adjacent side, and then this is the hypotenuse, so I'll say the cosine of 65 is 5 over, that would be little x. Now when you solve this, you're not multiplying both sides. Here, you can think of it as a proportion, or you can think of it as a two-step equation, okay? Multiply both sides by x, and then you divide. So 5 divided by the cosine is 65. 11.83. Now, one thing it's important to remember, the hypotenuse is always the longest side, so if I would have gotten like 8, I know that's wrong, because 8 is less than 10. So you have to have your triangle set up correctly. Just kind of to check it, let's do 5 squared plus this guy squared, and then when I square root it, do I get the same thing? Yeah, 11.831. Good, see? That means that I know I did everything right. Okay, so those are the 3 sides, and those are the 3 angles. Let's do one more like that. It says sketch a diagram. So anytime it says angle of elevation and angle of depression, the most important thing is you start by drawing a horizontal line, because angle of elevation from the horizontal means you look up. So this is the angle of elevation. Angle of depression means, ooh, that didn't work. From the horizontal, you look down. So this is the angle of depression. Okay, but it's always from the horizontal. And if you are in a word problem, those are congruent because they are alternate interior angles. So we're going to draw a picture. It says you're flying a kite 4 feet above the ground and using 500 feet of line. So we'll draw a triangle, and this will be my lovely kite, little tail. There you go. Okay, maybe too long. 4 feet above the ground and using 500 feet of line. At what altitude is the kite flying? Oh, I think this 4 feet is actually like here. Like you're standing like that. So this is kind of, we're going to add 4. This is 4 feet. Okay, so, and like you're standing here like this. Okay. You're flying a kite 4 feet above the ground and are using 500 feet of line. So this is 500 feet that connects you to the kite. At what altitude is the kite flying at the angle of elevation from your hand to the kite? So from here, you look out and you look up. This is 48 degrees. And we're trying to find the altitude, so that would be this height right here. And we're just going to add 4 at the end. So if we're using 48 degrees, h is opposite and 500 is the hypotenuse. So opposite hypotenuse is sine. We'll say the sine of 48 is h over 500. And now I will multiply both sides times 500. And I'll just say 500 times the sine of 48 is 371.57. h equals 371.57. And then because I'm 4 feet above that, I'll do plus 4. So 375.57. So this whole thing, the altitude of the kite is 375, and I'll just make it 0.5 feet. At what altitude is a kite flying? 375.5 feet. Okay, that one's worded kind of funny, but once you get the picture drawn, it's like all the other ones. Okay, so what I want you guys to do is try the practice problems. We'll go over those, and make sure you hit that like and subscribe.